Okay, so in this lesson we're going to look at 6.6, which is general form of a linear equation, outcome R6, R7. What we've talked about so far in the past was slope-intercept form. Do you remember what slope-intercept form looks like? Here, I'm going to write it down on a separate piece of paper just so that I have more room. So y equals mx plus b was slope-intercept form. And what was the other form that we just did? Y minus y1 equals m, and then x minus x1. What was this one called? Okay, and then we also had general form. Have we done much of general form yet? We've seen it maybe once or twice, no? Okay, general form is when you have ax plus by plus c equals 0. This is general form. And what we want for general form is we want this value to be positive. So we want to keep the a value positive. And then there's another one which we don't really use that often, but you'll see it sometimes. It's ax plus by equals c. This is known as standard form. We don't really use it or worry about it too much because really it's just one step away from general form, right? You just subtract c on both sides and you end up with standard form. So what we're going to look at today is general form. So we're going to take these two equations. This is in slope-intercept form, and we want to change it to general form. Now, the best way to work when you're working with equations is to work down. So what I'm going to do is I'm going to do part A over here, and I'm going to do part B over here, okay? So I'm just going to rewrite the question so I have y equals negative 1 over 4 plus 3. And what I need to do in order to get everything over, oh, I forgot to write the x here. I need to get everything over to one side of the equal sign, and then the other side needs to be 0. So ax plus by plus c equals 0. Okay. Now I have a 4 in the denominator here, right, for the slope. So what I'm going to do is I'm going to multiply everything by 4. So I'm going to multiply this by 4, this term by 4, and then this term by 4. So I end up with 4y equals negative, now these 4's reduce to a 1, so negative 1x plus 12. Now I need to notice how I've got a negative in front of this x. So that's what's going to make me decide to add an x on both sides so that I get a positive coefficient for my x term over here. And I'm going to subtract 12 on both sides at the same time, so then this ends up being 0 and this ends up being 0, right? Okay, so we want to write our x term first, then our y term, and finally our constant. So I end up with x plus 4y minus 12 equals 0. And this is in general form. And it's always nice to work down when you're working with equations. It just makes more sense. You don't want to be working across. It's hard to follow one step to the next. So I'm going to rewrite question B over here. And notice this 3 over 2, what is it doing with this bracket here? It's multiplying, right? But I'm not going to bother distributing this through this bracket. I'm going to multiply everything by 2. So this is a coefficient sitting in front of this bracket, so I'm just going to leave it there for now, okay? So multiply everything by 2, and I'm going to multiply this by 2. Now I don't need to multiply anything that's in the bracket because that's what this 2 is doing already. So we go 2y plus 4 equals, and what happens with this 2? It can reduce there. So then instead of writing 6 over 2, I can just write 3, and then I'm going to write my bracket there. So now I'm going to distribute this 3 through this bracket, and what does that give me? 3x minus 12. Okay, now I can move everything over to one side. Now which side am I going to choose to move things over to? So move these guys over to the right because I have a positive coefficient in front of my x term, right? So minus 2y, minus 2y, minus 4, minus 4. This is a 0, this is a 0, so I get 0 equals 3x minus 2y. Now I can combine these like terms. Those constants equal negative 16 or minus 16. Okay, now, so these two are now in general form. So everything is over to one side of the equal sign, and the other side is equal to 0. If you want, you can write 3x minus 2y minus 16 equals 0, but note that these two equations are exactly the same. Okay, next question. We're going to look at determining the x and y intercepts for question 2 here. Now, what do you remember about x and y intercepts, horizontal and vertical intercepts? So when I'm looking for the x-intercept, what do I do? I set y equals to 0, and then I solve for my x. Okay, so let's do that. So I've got x plus 3y plus 9 equals 0. So if I set y equal to 0, what happens to this term? Becomes 0. So x plus 9 equals 0, and then I end up with x is negative 9. So what's my x-intercept? Negative 9, comma 0. Okay. Now let's look at my y-intercept. So what's my y-intercept? What do? I set x equal to 0. Okay, so let's write down the original question. And then what happens to this x? It's 0. So I'm left with 3y plus 9 equals 0. 3y equals negative 9. Divide both sides by 3. Y equals negative 3. What's my x-intercept? Oh, sorry. What's my y-intercept? 0, comma, negative 3. Okay, so the next part says to graph the line. So we can graph the line using the x and y intercepts. So we've already found them. You've got two grids here just for fun. So there's no real rhyme or reason why there's two grids. So let's count out where our negative 9 x-intercept is going to be. So here this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So I go off the graph a little bit. So let's label this point, negative 9, comma 0. And then my x-intercept is 1, 2, 3 down. So it's over here, negative 3. Sorry, this is my y-intercept. Okay, now I've got two dots on my graph, so what do? Get a ruler, connect them. And what do I have to make sure of when I'm drawing a line? On the ends I need arrowheads. Okay, I need arrowheads because it's continuing. Now, third question over here says, determine the slope of the line with this equation. So, all right, now, I want to have a look at this in a couple of different ways. If I have my, what form of equation can we see the slope of the line really easily? Okay, so the slope-intercept form is y equals mx plus b, right? Now, if I have, can I change this to slope-intercept form? All right, so let's do that. I've got a negative 2y here. Now, I want to move this over to the other side. What do I need to do that? Add 2y on both sides. So now I've got 5x plus 12 equals 2y. Okay, great. Now, y isn't isolated yet, is it? What do I need to do? Divide both sides by 2. Notice I'm keeping all the dividing separately for each term. That way I'm going to be able to more easily see what my slope is because it's going to be the coefficient in front of the x. So this reduces to 1. What does this reduce to? 6. And then this doesn't reduce to anything, does it? No. So I can write y equals, and then I've got 5 over 2x plus 6. Okay, so what can you tell me is my slope? Slope is 5 over 2. Now, I want to make sure that you note that I'm only writing the coefficient in front of the x term, okay? The variable x is not part of the slope. That's part of the equation that lets you know that that's the rate of change, okay? So just the 5 over 2 is your slope. Now, I want to mention one thing to you as well. If I were to rewrite the original question right below, can you notice a pattern between what the slope is and the coefficients of the equation in general form?
Yeah.
So what's the pattern?
It's the coefficient of x and over the coefficient of
So,
y.
yeah, so the coefficient of x is the 5, that's over here, over the coefficient of the y. And what can you tell me about the sign, about the, like, notice how this is a positive slope, right? What can you tell me here? We're going to end up with the opposite sign that we have from these coefficients. Okay? So that's just, some people use that little shortcut when they're figuring this out. Okay. Now, the last question. Okay. You know what? I think I'm going to take a little break and